Hello. I will try to make a tutorial on wind generation with MetaSound. What will be kind of our end result? From breeze to storm with one control. I will try to make it as quick as possible, although brace yourselves because this is going to take a little bit of time. Yeah, let's go here. We have a nice folder and we are going to go directly into generating some material. MSS, Metasound source, wind toot. Wind toot. First is first. We are going to stick with stereo for the moment. And yeah, let's talk about wind 1 second. What is wind? On Earth, wind is a mass of air which is moving. We're not delving into the causes, etc., but how do we perceive, how do we hear wind? This is also a component because it's not only the air which is moving, but also us, how we are hearing it. And for example, uh, we hear different things at different times and different frequencies. And one character of wind could be howling, or can be just a simple breeze, or can be that specific sound towards the low end of the spectrum, that rumbling, etc. So we need to layer different things. Another aspect I want to talk about is we're not using sound files in this tutorial. We are using and taming the beast, which will be our noise generators. Another thing we are going to use is something which I should cover in a specific tutorial, but random clock. Random clock, which is MSP random clock. It's an a MetaSound patch. Sorry, confusing with other software application. A MetaSound patch, which let's open it. Has a basic period. It's based on trigger repeat, and based on a basic period, adds a plus or minus a certain amount of time every time there is a pulse. And this we can achieve. Trigger repeat gives the pulse gets out. At the same time, second block, the first thing it does, the repeat out asks random flow to spit out some values based on certain parameters and a certain amount, which is going to be added to base period, and again, so on, so on, so on, so on. Why is this a patch? Because it's a patch. We don't need a MetaSound source, and it works perfectly inside Presky. So what we need to do is layer several of these, and let's start immediately by, I have this habit which is using an ADSR as my DSP controller for this patch. We have wind, so 2 seconds to get in, 0 decay, 1 second to stay, 2. This is a habit I got from other trigger attack. Actually, no, sorry, it's not trigger attack, is on play. And we also have trigger release, which will be our stop all. Okay. Promote to graph variable, promote to graph variable, promote go to graph variable here. And where is our unfinished? I know there are many ways of controlling polyphony, voice management, etc. I have this habit, so leave me with this habit. It's just an extra fail-safe situation, most probably redundant. And this is our, I like to call it, DSP manager. Okay, yes, we have it all. Perfect. Let's say. Okay, so I start play, an attack triggered, switch on what you have to switch on, stop, fade out, undone, switch off the meta sound. And this is going to multiply whatever is arriving in there. I'm doing with the signal situation because yes, this such a pretty thing, la 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 la, and here we go. So let's build our Space Invaders ship. Here we go, and of course we will have a stereo mixer. Let's do it of 4. I don't know, we have the time to make so many layers, but we will try. Try or not try. Okay, so this is our destination. Now we need to build the layers. On play we don't need it. What we need is an attack triggered. And this is our random clock. We have our base period, random time min, random time max, and random time amount, which we should probably set to 1. Then variable, and let's keep ourselves in computer world, so pulse 0, timeout 0. Correct? Correct. Yeah, this is our hammer time manager. Okay, so let's start. Noise. Not going into technical details here. They sound the difference between pink and white, if you don't know it. They sound quite different. Pink. Brace yourself. White. Okay. A lot of high frequencies in white noise. In pink noise, of course, there's a slope, etc., etc., etc. So we need to do something they used to do in the old days. Hello, biquad. Biquad filter. If you don't know what a biquad filter, it's a 2-pole filter. Yes. Then we need to band pass. Bandwidth pretty narrow. Just for the moment. I'm going fast, so try to make it short. Let's give it a 3 dB. Yeah, with a bit of more energy. Let's go. What we want to do is but we don't want to do it by hand. We want to do it automatically. So let me be clear. This is my way of, one of the ways I do this kind of stuff. You can follow the Cologne school, total synthesis, or you can go the concrete school, use audio files, or you can mix both, or whatever. In any case, fun fact about Metasound is you can use whatever you want and control it however you want. Well, more or less. But pretty much you can do a lot of things. So what we need to do is we need to vary the cutoff frequency of this bicode filter, vary the amplitude of this. No, what am I doing? Sorry. Should multiply by float. Yes. And you know what? Give it also a little bit of stereo panning. Of stereo panning. But really just a little bit. So these are the three things we need to modify in real time with a little bit of randomicity. Why are we not using an LFO? Because LFO is a cyclical thing. We don't need a cyclical thing. We need something that goes from one value to another value in a certain amount of time, and this certain amount of time changes randomly with a certain kind of control. Again, there are many ways in how to do this, but this is my way. I'm more than open to listen to any kind of possible solution. I would like to promote this to a variable, just not to get the spaghetti patches. Spaghetti, I'm kind of hungry lately. Out left, this is out 0. Out left 0. Out right 0. Why? Because we are going to handle things also here in the stereo mixer, and we have a bit of outputs and inputs, so let's keep it like a pro. Okay, so let's start. So we want this value here to move, this value here to move plus or minus a certain amount. Okay, and this plus or minus is not only triggered relatively randomly, but also relatively to a certain amount, a certain random amount. So this, what we're going to do now, it's going to be more or less valid for amplitude modulation and for the panning positioning. Okay, so stick with me, we can do it. Cutoff frequency, we know that it has to go in here, and we need to add something to this. So first node, there we go, plus, easy. We also need to, what else? Clamp it. Good old clamp, that's easy. And we need to clamp it in values which we know are good in our domain. So this will go here. Before it goes here, we need to do a certain amount of things. It will also need to go there in a certain amount of time. So remember, enter 2. Very, very handy note. What is the amount of time? Guess what? Yes, timeout 0. But not 100%. I would like timeout to arrive there just a little bit. It's like breathing. It's arriving there, wait a little bit, and then start again. So let's multiply this by 90%, 0.9. This is kind of, in Italian you say a sentimento. It's a feeling thing. So you can definitely use your own taste and variables and make it as you wish. This is really something which depends on your taste. So what we need now is good old random float. Hello. There we go. Yes, and this value times my amount, random amount, times -1, negative, okay, plus or minus this value, positive. Okay, so we have minus and plus. And they are all going here. Okay, so if we get this pulse is, hello, generate value, generate value. Okay, this is the amount, and my amount is proportional to cutoff frequency. So I will have, sorry, let me change this because we are going to have cutoff frequency 0. We are in the world of computer. Additional operands will become a cutoff random amount. I'm making it long just because. So if I have this times 1, this will go from minus 236.7 to plus 136.7. Okay, so we really have it going to 0 and to 472 something. So we will, let's see, 0.99, something like this. Okay, and this we can leave it at 30%. Why? Just to play it safe. Okay, so for the moment we have, something which goes like this. Ooh, so howling wind movement. Cool. Maybe we can make it slower. We will also automate this stuff later. Maybe we make it 1. So we need, well, 2. What about 1? 1 is good. 1 is good. 6 dB. You see the values here, they're very low. Good. It's good because also we're scaling it. 50% less of energy is minus 6 dB. Let's do it 1. Okay, I am going immediately to do something. Gain 0. Gain 1. At least 3. Oh, managed to make 4. Well, let's do 3. Okay. So now we need to do something similar to modulate the amplitude. I'm not using the gain because I would like to use that. This is kind of stuff I want to have it fixed. So let's modulate the amplitude and then the panning position. So what we need is to copy all this, Control C, Control V. Yes, of course here we're clamping between 0 and 1. Let's give it like this, yes. And you go here. Shall we make some space? Yes, we should make some space. I think it's good if we make some space. Okay. Okie dokie, pokey wokey. Here we are. And we need an amplitude control and a random amplitude control. So, how do we do this? Go up here, amplitude, not amplitude, but amplitude 0. Yes, and amplitude amp rand am, which is not a fine company, but sorry, this goes here, this goes here, and this goes here. Perfect. Oh, we also have our amplitude amount, and our amplitude and our randomicity amount. Plus minus, yeah, maybe if we also need to use the brain once in a while. So 0. I'm not going to. This, you could automate this. So if this is 0, well, let's leave it like this. And we have our amplitude modulation. And what else? Maybe we should keep this clock. Oh, we are going to use a lot of real estate here. Let's move here. And now it's our panning moment. Because we don't want, we're not going to use the panning here as a direction, but as a variation in the perception of the sound. So we're not moving our head and looking somewhere at the moment. We're just having this thing moving a little bit to the left, to the right. Why? Well, because it creates atmosphere. And again, Control D. Oh, here's the fun thing, actually. I think here we can really keep it really simple. -1, 1. Remember, here we're moving from -1 to 1, from left to right. Keep it at equal panning, equal power. Let's keep it like this. We actually don't need this. So, and we will call it pan 0 panorama, which goes from -1 to 1. We leave it at 0, and we will have our. This time we don't need the proportionality. We actually just need the pan control. Pan rand am. Again, not a. Oh, here we go. And we can leave it at 0. Oh, that's 0.2. So we should have just a little bit of movement. There you go. There you go. Next pulse. You see, just a little bit. Fantastic. There you. Okay. Layer number 1 done. Okay. Howling. Now, layer number 2. And we need to copy all this without the outputs, because this is going to be something different. Control D, the power of Control D. Out left. No, sorry. Out left variable. Out left 1. keep on making the same mistakes. Not good. 1. Hello. Right. Left. Left. Nice and easy. There you go. Pop. Oh, I almost forgot. Once in a while save. Yeah, you've probably seen I'm using the 5.4 version, but this is stuff which is okay from 5.1, which is 5.0 on, of course. But you need to activate the MetaSound as a plugin, etc. 5.1 it goes by itself, and from 5.3 you can derive information and spit it out into blueprints, which is something very cool. So here we want now. Look at the amplitude stuff. Maybe we could actually leave it the same. Well, this definitely needs a different kind of control. We need the same pulse for the moment. Panning, we can leave it like this. We don't need to have it, etc. What we need to change. No, this should stay the same. Maybe we can change this. And now what we need to change is we need to put some processing here, because do you know what I'm trying to do here is when you turn your head towards the direction of the wind or a little bit, and your brain is not able to decode a certain part of the spectrum, so the low frequencies become a rumble and you have this thingy. So how do we achieve this? Well, I don't know if anyone got a better idea. For the moment, I think we should well, we could do it with well, let's do like this: wave shaper, distortion, a lot of distortion, hard distortion, limiter. Okay. Threshold, pretty hard, etc., etc. We need to test and taste. But first we need to create this, which we will call cut off frequency 1. And we should also have our cut off frequency, random amount, cut off random amount 1. Yes. Let me put the 0 here. Why? Because yes. Just to keep it, 0, 1, 0, 1, 0. Amp random amount 0. Up, and we should have forgot almost 0 and 9. And let's see like this. This should go. Whoa, 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 whoa. I was forgetting something pretty important. Our range. Frequency log. There you go. This should go really in the low part of the spectrum. And are we there? We are there. Let's see how it sounds. Let's hear how it sounds. So, remember, I changed this. Now what would be cool if we, yeah, it's okay. Now, done this, we could create some more complicated relationship between frequency of the howling going up, which means more sound pressure, more air pressure, and this amplitude going up. Okay, that's an idea. Maybe you can develop. Otherwise, this is going to take like 3 hours. This tutorial, but something which one should definitely work on. And yeah, now we need, um, let's call it the breeze layer. The breeze layer. And we are still going to need a noise generator, a bicode filter, a little bit of movement, randomicity, all this. Then we are. So it's quicker if I do like this. Remember, don't copy this. Control C, Control V. Ooh, where did you go? Let's call it howling. Let's see, howling wind, howling. See, rumble. Mm. And this should be. Should I make it a little bit blue because it's in the high frequencies, and this is reddish. You have pretty. And now new parameters. Go away timeout because we need another pulsar. Pulse. Well, this we can keep it. This we need to get away. This away. Oh, hang on. This should not be pan zero. Oh, well, we don't need. It doesn't really matter now. Well, it doesn't change. So we have these guys here, and this is going to be a pink noise, and it's going to have. We need to cut off a lot of low frequency. So one full high pass filter, I would say, and let's start with 100. This becomes a low pass. This goes to 0. This goes to 1 because otherwise it's gonna make a whistle, and we don't want the whistling, the resonating frequency. So say whistle just to focus in our mind what the hearing result will be. Out left from a variable, out right from a variable, and you are out left 2, and you are out right 2. And we need now a new clock. We need a new clock. Control D. We need a new pulse. I am going to call this pulse 2 because maybe one day, who knows, I will add another clock even for the rumble. Who knows, just to make it even more complicated. And yeah, so this is our clocky. We will need to change this. So that's okay. We can leave it like this for the moment. We definitely need to give a new cutoff frequency. Two. English. Need to practice a bit. So a cutoff frequency, there you go. This goes in here. And here we have a, why don't I do cut off random amount. 0.9. This goes from 20 to 20,000. You know, where's my 20,000? 234. Okay, and let's see. No. Log. This is where math makes its magic. So, pink noise, low pass, 0 dB, 1 bandwidth, cutoff frequency 2, cutoff, and now our amplitude module. Oh wait, how do we trigger this stuff? Pulse 2, timeout 2. Come here, pulse 2. Come here, timeout 2. And yes. So why am I doing all this? Because then I want to show you how to control all this amount of stuff with just one Lord of the controls, of the knobs. I did a patch long time ago, which was for Max for Live, which was called Lord of the Knobs. Definitely not a lot of fantasy there. Amplitude. No, 2. Amplitude modulation. Come here, amplitude modulation. Amplitude 2. Am I allowed to amp rand am 2? I'm leaving it like this because I don't know if I want to make it. Oops, this is all 2. So, maybe this, it's a bit too much, huh? This is okay, and then pan random amount. This we can leave it as something standardized for everyone. Graph input, pan 2, minus 1, 1, minus 1, 1, leave it at 0, and there we go. And of course we need our pulse and timeout 2 and pulse 2. So yes, stick with me, we can do it, we have to do it. And where are you? Right 2, right, no, sorry, left 2. Tick tock tack. Okay. It's really much. So here's the cool thing, that what we want to do with one control is to, when it's breeze, when it's a breeze situation, this is going to have something like this. Nice, so when it's stormy weather, once in a while we can have this. When it's stormy, this comes off. This comes off. Everything moves a little bit faster, and we can open also here. worker, etc., etc. All with one control. So, okay, now it's time to make our super lord of the knobs of controls. Come on, let's unlock. Let's call it this default. Let's give it two. Yes, so we have, and default is 1. Linear, there you go. This is our master of disaster. First thing is, let's drop it where we need it. Breeze is always breezing, so it's always on. Okay, we give it again just to handle it. Could use a master again. It's okay. Let's leave it like this. But these guys need to get up multiplied by this. So instead of using multiplication and addition, we are going to use a map range. Why? Because it's good to have it. 2 and times, but we still are going to have times float. Yes, okay. And this, let me, lock shift now. Control D. This is our hauling volume control. But this is going to be like this. There's always a little bit of rumble. Maybe even 2. So the minimum, oh, not 0, 1, 1. Let's do it like this. Again, this is a sentimento. It's a matter of taste. No, just to make it clear. Lower this towards the nice 0.707. Magic numbers. And this, I think we could leave it even to 0.3. There's always a little bit of bass going on. Okay, me like. Then we said we need to control this cutoff frequency. Same principle. This times this. We set the default value, map range, minimum and maximum. How can we do this? The easiest thing would be to multiply, to be honest. With an offset, yes. Well, this is one way for sure. So, for example, okay, this is here, we put it here. For example, this times here. If I have no, but if I multiply it to 0, that would actually be not a good thing to do. Because this times 0 is 0 plus 20 is 20. Doesn't make much of a sense to me. No? So we should map this, map and range, or give it an offset before, which would be also possible. What do you think? Okay, let's do like this. We should improvise 1 second, which is always good to improvise and try out things. So I want, well, actually I could do this, map range, load, cool, okay, 0 to 2, and it could go from a he. Again, also something cool. This times 0.15, this could be cool. Yay. So we're using the same system that we're using here. We're just making it more complicated because it's cool to make it complicated. Beep. Bop. Map range. This is, well, it's not plus, it's actually times. No, it's plus. Ooh, interesting. And we don't even need a map range. We actually need just this. Cool. This should be correct. So if it's 0, and this we can put it like this. Let me see if it's right. This is why it's opening, no? Correct? Yay! It's probably another way to do it much better. Okay, this looks like something which could achieve our scope. So I'm sure there is a mathematical better way to do this. But now it's cool if we make mistakes and learn from our mistakes. Okay. And this is also why we are keeping, I lost my mixer here. Here we are. This separated from that. This I think it should be higher volume. And this should be a little bit. Okay, so okay, now we have our stormy situation. What else? We need to change our clocks. How fast should they go? Well, I would like this to definitely be faster when this is up and slower when this is down. So, map range float. And we go from 0 to 2, but we want to invert the situation. So, when this is 0, this clock should have random time max equals 5 Yes, and when it's faster, random time max should be like something like 2. Why not? And this is max. Then we also have random time min. When this is 0, sorry, yeah, uh, this should be minus, remember, if you remember this clock, this is a multiplication. So when toot, so when toot, this should go. Ooh, I thought Unreal was crashing. Uh, faster means times 0 minus 0 point. No, 75, and minimum should go 0 very slow, minimum 0.25. Okay, but we also want to speed up the base period. Wow, this is getting, oh, okay. When you're slow, base period should be something like 1, and if it's faster, should be something like 0. Who knows? 5. Again, stuff which you should and must. We're keeping this at 1 because this should be a totally random situation. Control C, let's go down here. Click, Control V, perfect. Shall we apply the same values? Well, let's leave the same values for now. Base period, random minimum, and random max. Breeze. Breeze. So I hope these 53 minutes, wow, this is a record-breaking tutorial. Yes, but we did a lot of things. So I hope this wind tutorial is useful to someone. Sorry. I'm super happy if someone wants to debate, discuss, or dismantle everything. But I'm open to any suggestion. Thank you very much. Thank you for your hour of time. Ciao, ciao.